Okay, ladies and gentlemen, welcome to Electrical Circuits. This is just a little background knowledge, and I'm going to be doing this, I guess, weekly. And basically, what I want to do is slowly give you a introduction and slowly get you acclimated to electrical circuits. So it'll be little bits of information, a little bit at a time. Okay, so first of all, I'd like to talk about a circuit. The circuit kind of goes around like that, and not necessarily in that direction, but it goes around like that. And basically, one of the major components of a circuit is a conductor or wire. So if we took this and we just boom sliced it in half and we looked at it sideways, you'd have a metallic material in the middle, in the center, and this is the conductor. Like the train, a conductor. Okay, so we have the conductor, and that kind of carries the current through the whole system. All right, so that is a conductor, and then we have an insulator. Alright, you have a conductor and you have an insulator. If we take this wire, chop it, turn it sideways, face to the camera, I'd be holding it kind of like this, pointing it at you, and you would see the cross section, the insulator, some rubber, some type of rubber, something that does not conduct electricity, and it keeps it contained. So the insulator is like a container. It contains the electricity into this confined into that area. Okay, so the conductor, that's one of the major parts of a circuit. We got to get the electricity around to the different components of the circuit. Alright, so that is our insulator. And so then we are going to talk about how do we power this stuff. Okay, so we're going to put a battery. And what is a battery? A battery is a container. And basically inside that container are chemicals. And what the battery is set up to do is it uses those chemicals and turns the chemicals. The chemical takes the chemical energy, and it transfers it into electrical energy. We have a positive and negative terminal. I don't care if this is your 9-volt battery and your tape recorder, or that'd be like AA's or AAA's, your D batteries and flashlights, your car battery. Alright, you got a positive and a negative side, or terminals, like on your batteries and stuff like that. And so that's what's going on. Chemical energy transferred to electrical energy. Okay, so that's the battery out of the way. And then we have a switch. Bang, bang, bang. So that's a symbol. That is our switch. This is what our switch looks like. And a switch makes or breaks the electrical energy going around in the circuit. It's breaking it right now. This switch is considered to be in the open position. So in the open position, there's no current flowing through. And then when we take this circuit and we flip it, just like your light switch in your room, switch on your computer. It's a switch. When your computer's off, the switch is open. When it is on, this switch is considered to be closed. Alright, and then we have electrical energy flowing through the conductor. Okay, so conductor, battery, switch. Next thing we're going to talk about is that is a symbol for a bulb, or what I should call it a light bulb. Alright, so when we close the circuit, when we close the switch, electrical energy is flowing through, and then the electrical or the current is going through a filament, and when it hits that filament, boom, we get light. Sometimes in the bulb you may have an inert gas like neon, right? And electricity goes through the filament and lights the gas up. So neon is just like super bright, and you can have nice little colors and stuff like that. So that's our light bulb. I feel like Forrest Gump. That's all I have to say about that. Notice though, I want you to pay attention. We have straight lines, and boom. Now, see these curls in there? Well, normally the current is going at a certain speed, and it actually slows down because these curls in the filament provide what we call resistance. Because, hey buddy, you gotta slow down. Moving too fast. Slow up. It's like the cop posting on the side of the highway. You know, everybody's like opening up on the highway, then when they see the police, they kind of, oh man, there's a cop. He might have his radar gun on. So we slow down. So the bulb provides resistance. We also have something called a resistor. And the symbol would look something like this. And the same thing happens. Just think of the straight path. Boom, we can just hammer down on the gas. But then when the current gets here, it's gotta slow down. Just imagine it slowing down. So the resistor actually reduces the flow of current. In addition to that, it drops voltage levels. Alright, so just trying to think a couple more things I would like to add. Just for our purposes, conventional flow. How the electricity moves through the circuit. Alright, we have our negative terminal here, positive terminal here. So for conventional flow, we want to think of this as the current going in that direction. Okay, so this is called conventional flow. CONVENTIONAL. That is the conventional flow of electricity. Now, honestly, what is happening, I won't go into that. For our purposes, this is the flow of the current. So conventional flow, and I think I'm gonna stop right there. Yeah, I'm gonna stop right there. So I didn't define the resistor. Yeah, I did define the resistor. The resistor reduces the flow of current and it lowers the voltage. So in future videos, you're gonna see how that happens. But for right now, got conventional flow. Yeah, battery. There's a 12-volt battery. All right. That's our voltage. Current is measured in amps, or we call it amps or amperes. But amps we say for short. We say amps for short. And resistance. The resistor, we define what that does, is measured in what we call ohms. So let's call this a 4 ohm resistor. That's the omega symbol, as best I could draw it, but omega, that is the omega symbol. So just to back up and recap. So we talked about the conductor. We cut it in half, we split it in half, we showed you how there's metal inside and insulation on the outside. So what you see is the outside of the, when you're holding a wire. Here, give you an example. Here's a wire here. Alright, what we see is basically the outside. We see the outside insulation. We don't see the metallic materials that are inside to carry the current. So this is like a rubbery substance because this insulation does not conduct electricity very well. So what it does is it keeps it contained. So if you ever saw a wire where you saw metal exposed, then that's a bad wire. You want to get it replaced. So that's the conductor. We talked about the battery. The battery takes chemical energy, transfers it into electrical energy, and it's used as a power source. The switch. Our switch could be closed or open. The switch makes or breaks the electrical current going through the circuit. It could be open and stop the flow, or give it closed and let it flow around through the circuit. And then finally, our resistor, it reduces the flow of current and it drops voltage levels as well, and we'll talk about that. And this is what we call a series circuit. This is a series circuit because there's only one path for electricity to flow. Series, not the World Series. This is a series circuit. It's only one path. So that's it for right now. I'd like to thank you guys for watching. I did this video before the camera was like totally off. It was like out there somewhere. So I'm glad I got this completed. There's going to be more videos on electrical circuits to come. And I'd like to thank you guys for watching. This is Kieno Thomas. Oh, and happy Thanksgiving to you all. Thanks. And don't eat too much turkey. Bye-bye.